Hello guys, can you tell me what the equivalent resistance of this circuit? Or maybe some of you can tell me what the equivalent capacitance of this one? How to solve problems like this? Today I will teach you a method that will level up your solving problem skills about circuits. I will teach you a method, and the essence of this method is that you have to think in terms of potential. If you connect this circuit to a battery with EMF epsilon, for example, so here you will have the potential epsilon, right? And also it means that everywhere here, here as well, you have the potential EMF epsilon. Epsilon. Green light is epsilon potential. But here is zero, right? And when you reach a resistance or capacitance or inductor, right, you will lose some potential. You will lose the potential. So here you lose potential by the amount of the voltage drop on this resistor. It's current on this resistor times the resistance of this resistor. Anyway, you will get different potential here. This potential will equal to it's connected to another terminal of the battery, so it will equal to zero. Here it's zero, right? So here EMF, here it's zero. So at this point here we have zero potential, and at this point we have epsilon potential EMF of the battery, right? How about this one? We can see that it's connected to zero potential here and to epsilon potential here. How about the middle one? The middle one is connected to zero potential from this side and to EMF potential, epsilon potential with this side. So actually all these three resistors, they are connected to the points with the same potential, right? So they are sharing the points with the same potential, the points with the same potential difference. What does it mean for us? It means that they are all connected in parallel here. They are all connected in parallel, and I can just rewrite this circuit as parallel connection of these three resistors. And what I will get here, I will get R over 3. The equivalent resistance of this circuit is R over 3 ohms. How about this one? How about these capacitors? What is the equivalent capacitance in this circuit? Well, you can think the same way here. In here you have epsilon potential, and here you have zero potential. Let's start thinking about it. So also it's epsilon potential here, and everywhere here it's epsilon potential until I will reach a capacitance. When I reach capacitance, I will lose some voltage, I will lose potential, right? So I will lose potential here and here by the amount of the voltage drop on this capacitance. And if these capacitors, if they have the same capacitance, it means that I will lose potential by the same amount here and here. So actually it also means that I will have the same potential here and here. Let's say it's just phi or phi, you say phi, right? Phi 1 and phi 2. And phi 1 and phi 2, they are equal to each other. Okay, how about this side? If we go from here, from zero, we will gain the potential by the amount of the voltage drop on this capacitor, and here we will gain the potential by the amount of the voltage drop on this capacitor as well. So it means that the potentials here, they are the same. Phi 3, phi 4, they are the same. Phi 3 and phi 4 equals phi 3. But also I can say that they equal to phi 2 and phi 1 as well because of the symmetry. Can you see? It's absolutely the same here as here. So what does it mean? If we have potential phi 1 here and phi 1 here, it means that the potential difference on this capacitor is 0. It means that actually it's the same as we have no capacitance here. We have just this one, this one, this one, and this one. And now if you erase this capacitor, what will you get? You will get two capacitors in parallel here, two capacitors in parallel here, and these two pairs will be connected to each other in series. So in parallel, CC in parallel is double C, and double C in series. This is just C. So the equivalent capacitance of this circuit is just C. The equivalent resistance of this circuit is R over 3.